So glad to be here. Lots of first times for me. First time in Romania, first time in Cluj. Very happy to be here. Thanks for having me. Also, the first time that I'm speaking at a conference that does not have React in its name. So I'm really looking forward to broaden my horizon here. And yeah, also the first time that I'm standing between the audience and their lunch. So I'm really trying to make it worth the wait. But what I always do when I'm on stage is I take a photo of the audience to remember this moment. So this is really wide, so I need to take it back. So give me your best audience wave. Woo. OK, that was great. Thank you. This doesn't work. OK. Also, the first time that my laptop didn't plug in here, so I had to take another one. So wait a second. I think this is just not turned on. There, now it works. OK, that's better. My name is Dominik. I'm a software engineer from Vienna. You can find me as TKDodo online almost everywhere. I write a blog at tkdodo.eu, where I write mostly about React and TypeScript, but also occasionally other things. And for the last 5 or so years, I've been maintaining the popular open source library 10-stack query, or React query, as it used to be called. Now, just oops, that was wrong. Sorry. So maybe just a quick question. Usually, I've never done this in a non-React exclusive audience. Who has used 10-stack query before? So raise your hand. OK, wow, that's still a lot of people. Great. I'm not here to talk about React query though today. You can come to me, talk about it later. I also have some 10-stack stickers. If you want some, come pick them up. But I want to talk about something else today, because beginning of last year, I joined the design engineering team at Sentry, where we're not really directly working on a part of the product, but instead, we want to make ship happen. We want to enable other teams to ship efficiently with the Sentry codebase. Now, in that sense, I see myself also a little bit as a developer experience engineer. And our team actually aims to make 2 things happen. We want to make it easy for product teams to ship the right things efficiently and consistently, and at the same time, make it so that they don't ship the wrong or inconsistent things and guard them towards this pit of success per default. Now, to get there, our team basically has 2 goals. We are building a design system for Sentry, the library of consistent components with good APIs and documentation and type safety and accessibility built in, because components need to be easily discoverable so that humans and their agents can ship efficiently with them. That was one of the biggest problems in the Sentry codebase. And for the second part, we are actively working on constraints. So that means setting up TypeScript and linting correctly, but also about the project structure, documentation and skills, and teaching is also involved in that a little bit. So in a nutshell, we try to get the overall codebase of Sentry that has grown organically over the last 10 or so years into a good shape, so that everybody, people and their agents, can ship efficiently with it without breaking things. Now, to get there, we need to touch a lot of parts of the codebase regularly. So for example, the first PR I made when I joined Sentry, I touched over 900 files of code, because they didn't have the no implicit any compiler setting turned on. So I joined and I was like, on this scale, how can this not be turned on? So I made that big PR. And I made other big PRs as well. And while I was doing that, I really thought, like, OK, maybe I should sanity check some of the places that I've been touching or do some QA. And I tried to find out where the code is used. And it turns out a lot of the time, it wasn't used at all. Like, for example, when I enabled the lint rules for React Query, the ESLint plugin query, I found some violations. So I can also, if you're using 10-stack query, can really recommend that you're using our ESLint plugin. It helps find some anti-patterns and common problems that you might have with the library. So we had some violations, and this use has profile chunks hook. I wrestled with it for a little bit. I fixed the issues. And then I thought, OK, great. Now where is this used in the codebase? And it turns out it wasn't used at all. And that's when I thought, OK, like, no more. I can't do this. We need to clean house here. This is slowing me down. It's costing me time. Because unused code has a real cost. It means that developers will spend time reading and trying to understand, and maybe even refactor code like I did, that shouldn't be there in the first place. And I think this is even more important in the age of AI, where generating extra code is easy, but maintaining it later is hard. And every unused line of code must still be read and maybe consume context and tokens. Now, things like library upgrade or changing lint rules becomes more painful the more usages we have to adapt. Because TypeScript and ESLint, they don't care if code is used or not. If it exists, it has to be error-free. And it might even increase your bundle size if it's not properly tree shaken out. For example, if you have side effectful modules. So all in all, I think unused code has a real cost, it slows us down, and it's a pain, and that's why we should care about it. But how did we end up here? Well, I like to believe that developers are actually responsible humans who try to constantly clean up after themselves. But in reality, we need to be constantly reminded about the most basic forms of cleanup. But I think that we are rightfully so driven by errors, because TypeScript has given us this great boost in confidence. And one of the biggest advantages of TypeScript is that it makes some dependencies that used to be implicit in our head explicit in code. Like, I change what a function returns in one place, change the implementation, and then I see all the usages that I need to adapt to make it work again. This was incredibly hard in code bases without types, especially if they were large. So that's great for our confidence here, but I think we've come to rely on it a lot. And it's not only types. It's also all the linting and testing and the static analysis that whatever guardrails we have set up in CI that lead to the fact that if the thing is not read somewhere in the pipeline, we are not going to look any further than that. And yeah, that's it. That's how plain and simple I think that code sticks around. If nobody tells us to remove it, we just won't do it. Now, you might be thinking, hold on a second, doesn't TypeScript catch this, right? There's my good friend TS6133, something is declared, but its value is never read. This is something that we see all the time when we forget to remove an import or something. So we must be good, right? This is the same thing. Well, yes and no. So I have a simple example. It's a React component where we have a file size component and a util function that it uses called format bytes. Doesn't really matter what it does, but the concept is that if this file size component is the only one that uses this util function and we remove it, then yes, TypeScript will tell us that this function is now unused if we have the no unused locals flag on in the TypeScript settings, and then everything's fine. But what happens if we change a tiny thing? If we add an export statement in front of the format bytes function? Then we will not get any errors because TypeScript simply does not do cross-module usage analysis. If a function is exported, TypeScript will just assume that it's used somewhere else and will never report any errors on it. And I think that's a problem. Maybe not in this simple example where we might just remove it, but what happens to util functions usually over time is, they get reused, and then they get moved to different places, hoisted up. They get moved to their own utils file, right? Maybe even a top-level utils file, which I really hate. And then they become global. And then you have a couple of usages, and then over time, those usages go away because code changes, features change. And then what sticks around is this top-level util function called format bytes that nobody is using. Yeah, and that's it. I think that's how that code sticks around. It's the easiest way to produce that code. And I think AI does it all the time, right? Take one approach, take another approach, leave some exported functions behind. They're unused. Now, good IDEs can help with that. For example, IntelliJ creates an index of everything, and once it's done with that, it takes some time, but then it can mark those things visually. But it's still up for developers to act upon it. So I thought, this can't be it, right? Surely somebody else must have had the same problem. I'm not the only one, and somebody built a tool for it. And yeah, there are tools that have been around for quite some time, like tsprune or unimported. We're tackling this, but what they have all in common now is that they are either archived or in maintenance mode, and they all recommend Knip by last coupled instead. So what is Knip? Well, Knip is a comprehensive tool to statically analyze your code for unused files, exports, and dependencies, and then report them to you so that you can delete them. It is quite fast. The latest version takes around 6 seconds in the Sentry codebase, which is quite large. It aims to be zero config, but in any larger project, you might need a bit of configuration for it. It has lots of plugins and also support for monorepos and is auto-fixable. So I think that sounds like a great sales pitch, but how does it actually work? Well, under the hood, at its core, Knip needs to know two things. It needs to know which files are part of your project. Now, how complicated that is usually depends on how you've set up your project structure, but it can be as simple as like all your TypeScript files in your source directory. And then the second thing it needs to know is what are the entry points to your application. And what the entry points are usually depend on which framework or bundler you're using. I mean, if you're using something like maybe Next.js, all the pages and layout files in your app directory might be an entry point or have to become an entry point. But if you're just using Vite, it might be as simple as just your source main.tsx entry point file. And once Knip knows that, it will traverse the project, starting from the entry points, to build a graph of used symbols. And once it has that, it will then report on the things that are in the project, but not in that graph. So in this simple example, it will go from these 3 entry points, see all the used green stuff, and then it will report on these 2 red dots because they are in the project, but not in that graph. And that's pretty much it, and it works remarkably well. So one question then is, how can it aim to be zero config, right? And where do all those things, entries and project come from? And the answer is it uses their plugins. So it has a lot of plugins. And what the plugins do is usually they look at, it looks at the package JSON to see what you're depending upon and then configure itself accordingly. And it has a plugin for most of the tools that we love. For example, if it finds that you're depending on vtest, it will try to see what the entry points are, where the tests are coming from, because that's how vtest works. And if it sees that you're in an Astro project, it might try to infer the entry points from there. Yeah, and what those plugins usually do is configure exactly those things for you, project and entries. And if we take a look at, for example, vtest, this is the configuration that will be produced by it. It will know where the tests are because that's how vtest works. And of course, if you have a custom config, it will load that to see if there are any other entry points that should be produced from there. OK, enough talk for now. I'm going to have a short demo prepared to show you. If I can get it to work on this machine, let's have a look. All right, looks good. So I have checked out these. This is the Sentry code base. You can check it out yourself. It's open source. It's on GitHub. But what I did is I had to cheat. Is that big enough? Yeah, it looks big enough. OK. I had to cheat a little bit and go back in time, because right now we have no violations. And to show you how Knip works, I went back in time to the Sentry repo when we still had violations. So what we can do now is we can run the pm Knip script, which is just reps Knip. And it will show you a couple of errors where we have some unused exports. So we can now go into this vitals card component and see what kind of errors we have. And we can already see here in the IDE that, OK, this is marked visually as an unused function, frontend cards. OK, so we can just go and remove that. And then we're going to see some other things that are being also unused because they were used in there. And now we can see the red squiggles from TypeScript. We can see the TS6133, that this is unused. So we can just go and remove all of those as well. OK, then the next thing we had was these backend cards. You can also go there. OK, now I'm at a different line. Doesn't matter. Backend cards, going to remove those. And then there's the mobile cards function, also unused. Those were the 3 things that Knip reported. And now our goal is to get to 0 red violations. So let's look at here. There's a function generic cards that was probably used by all of those. OK, so let's remove that as well. And then there's some more things. Oh, God. So this is turning into a cleanup spree. Like, it's just a sparkline chart. We don't need that. OK, more red stuff, container. Ooh. It's just the gift that keeps on giving. It's just, you can just remove all the things here. Just delete the whole file, please. There's some more red stuff. Vital card, OK. It's, ooh, more stuff. This is oddly satisfying, you know, just to go through code and remove it. It's so great. Styled components, hate those. More props, go away, go away. More red stuff. So we're working towards 0 red stuff, and then look at all of these imports. I hope the shortcut works. Does the shortcut work? Yes, the shortcut works. OK, remove all the unused imports. And then more types to clean up. OK, are we done? Are we done? Yeah, the red is gone. OK, woo! Let's take a look what we did. So we went from 565 to 188 lines of code. I think we removed almost 2/3 of lines of code from this component. Right. So now we're done. That was a nice cleanup. We're going to push it, whatever. But maybe, you know, we removed a lot of imports, right? So maybe this is, even if you do this, like this is usually where it ends, because you won't go and check all the imports that you had, right? So let's take a look and run Knip again, see if there's anything else that it tells us. Oof, there are lots more things that it finds now. So apparently, we have had this sparkline component that was completely unused. Let me just see, I need to select the open file. Yeah, so we had this sparkline component, right, that was used. It was the only one that used this sparkline thing. So now we can just remove the whole directory, because this was the last usage that we had. And even better, we now have an unused dependency in package.json. This React sparklines thing was apparently unused, but nobody knew about it. Maybe we've been updating it forever. And you know, fewer dependencies is not a bad thing these days. So let's remove that. And then there's 2 more in the utils file. Let's look at those. This is get default display for pattern. And this is an interesting one, because it still has a local usage. It's not completely unused, so we can't just delete it. But what we can do is we can remove the export in front of it to keep it local so that it doesn't get imported accidentally or whatever. And then the next cleanup will be easier if we try to work with that. And then there's vitals card details, again, something we can remove. And then, as usual, there's more stuff can be removed. Ooh, more things. More things to clean up. Yes. OK, that's it. As usual, when we remove imports, what we're going to do is run Knip again. See, you know, maybe there's some more things it tells us. I don't know. OK, excellent. Knip found no issues. That's the thing we want to see. And then we know that we're done, and we've cleaned up everything that we can. OK. Now, I think that was great. There was a lot of fun to clean up all this dead code. But you know, maybe we didn't stop there. Because what if we could do better? There are some situations where, you know, I don't know if you're doing this, but maybe you're writing some tests. I think with AI, a lot of people have been writing way more tests these days. And when we're writing tests, what happens is that we might have some code that has a test, but is actually unused in production, right? And the only usage is the test itself. So at that point, yeah, we are not only maintaining the dead code, we also have to run it in CI, because essentially we can remove both the test and the usage itself. And then we have to run it in CI, and then we might have flaky tests, and like, this is not only dead code, but we are wasting a lot of time doing that. So what if Knip can detect those usages as well? And yes, it can do that because it has a dedicated production mode, where it focuses only on the things that we are shipping to production. Now, to set that up, it needs to actually know which things are production entry points and which things are production files. And so we need to configure that a bit separately. It wants us to add an exclamation mark at the end of all of our production entry points and production projects. The plugins do this mostly for themselves. But if we have to do this manually, from the example from before, we have all of our source files in TypeScript now with an exclamation mark at the end because they are for production. And then the main.tsx file is the production entry point. And then we might have some separate things in a build directory, some JavaScript, with a script that's using them that does not have this exclamation mark. Now, this works relatively well if your project is nicely structured. At Sentry, it looks more like this, because we don't have any places where we put our helpers and fixtures and also our stories. So we need to explicitly exclude them at the beginning with a leading exclamation mark for production with a trailing exclamation mark, which I know gets a bit more complicated, and that's where most of our custom config that we have comes from. But I think it's really worth setting up because we found lots of that code. For example, we had this get incident discover URL that was a function that we had in the code base. It had a test, but it was not used anywhere in the product. And actually, I think about 2/3 of the code removal that we did in total came from production mode. So I really think it's worth setting up properly. OK, now I think all of this sounds actually really good, and removing that code is a joy. But since this is a real-life story, we have to acknowledge that not everything went well, not everything went perfect, and that there were some problems and limitations that we encountered, and I want to talk to you about them as well. The biggest one is probably that it influences how we work. And Sentry has hundreds of people contributing to the code base regularly. So any change in how we work is potentially disruptive. Now, one of the things that we tend to do was to add code in a PR without actually using it because we wanted to use it in a future PR, maybe, like some preparational work. Now, for Knip running in CI, it cannot distinguish between really dead code and code that is still that is unused, but we still want to use in the future. So I removed some features that I found that I thought that they were unused because they were added 6 months ago. But the PR got closed because it turns out it was just deprioritized in the product, and there were still plans to use that code. Now, when you run Knip in CI, I think working that way doesn't really work out that well. What you can do is you can put some things into the ignore list, or you can mark things with an @public.js.doc comment, in which case Knip will leave those alone. But I think it's probably better to just write used code and ship your PRs as isolated units of work, and if necessary, hide things behind a feature flag. Because at the end of the day, if you put in comments like this, this will prevent the function from actually being cleaned up when it becomes unused explicitly. Another thing that I've noticed is that we sometimes tend to just add export in front of everything. Just instead of writing a const, we do export const. I don't know if that is because of copy-paste, or I think AI just maybe does it all the time, because why not? And when you do this and you run Knip in CI, it will report on those, obviously, and then you will have to go back to your IDE and remove all the exports and go back to CI and run it again. And this creates a very slow feedback loop, which can be very annoying. Now, to address this, at Sentry, we have created an optional pre-push hook that people can use, and before they push some code, they can run Knip to see if it will violate anything. And that has helped a bit with that. But also, Knip is getting better, and it now has its own language server, which powers their MCP server, and also the editor integrations for VS Code and IntelliJ. And that means we can now get those red squiggles right in our IDE if something is unused, which is a really cool improvement. Another thing that sometimes can get tricky when you're using Knip is if you're exporting something only for testing, especially if you use it with production mode. Now, to understand that, let's take a look at the example I had before with the file size component and the format byte function. And let's assume you want to write a test for this format bytes function. What you're probably going to do is add an export statement in front of it and then import it in a test file to write the test. But in production mode, per design, all the test files are excluded, so Knip won't see them, so it will flag this export as unused. And this is a problem if you have a large code base where this is done a lot. But I think the best way to address this is to not test implementation details, like these format bytes functions, but focus on the public interface that every other parts of the code base are using, which is the file size component. Now, I know that probably 50% of you will disagree with that, and that's fine. What you can also do is throw an add internal comment at those functions, because that means that they are not meant for public consumption, but only for internal usage. And they will still be reported normally when they are completely unused, but the internal comment is made specifically for production mode for situations like this. And another thing that I found out afterwards that we're now using in Sentry, because this has actually stopped the adoption of production mode for quite some time, and we found an extra 10K lines of code after I enabled the ignore exports used in file flag, which is something that we only use for production mode. But with this option enabled, Knip will not report on an export if it's still used within the same file. So even if you export the format by its util function, because the file size component still uses it, it does not report it in production mode. And with that, we found a lot of things that are totally unused apart from tests, which is what it's meant for. Now, apart from influencing how we work, we also had some technical issues that we ran into that I quickly want to share with you. One of them is about dynamic imports. And dynamic imports generally work well with Knip, but there were some edge cases where it didn't pick up on something. For example, we had this init file where one of our entry points, and where we trigger a dynamic import promise early on purpose, and then we await it conditionally later. Now, Knip didn't use to keep track of where this init variable is used, so it reported everything as unused that's used within this initialized main file. So our fix there was just to add this to the list of known entry points. But it's also worth noticing that this is no longer necessary because Knip keeps getting better over time and still is, at this point, is tracking this correctly. But another thing that we also stumbled upon where we do some very dynamic things was when I accidentally deleted some forms that I then had to revert because of something that we're doing with require.context, which is a very dynamic feature of Webpack where you can import a directory and have a regular expression, and then it will require all the files for you. Now, we did that for all of our forms, and Knip didn't know about this, and also some of the files were marked as unused. I thought they were unused, I removed them. And yeah, that didn't turn out so well, so we reverted that afterwards. But the bottom line is that I don't think doing such dynamic things is generally a good idea. This is also the only place where we're doing this. And we're working on the new form system with 10-stack form at the moment, so I hope this is going to go away. Because eventually, if you do all of these very highly dynamic things, you don't get static analysis on them, and even developers don't know if this is used or not if they just look at their IDE and try to find the usages, because this dynamic thing kind of like hides that. All in all, I think we made over 50 PRs over the course of 6 weeks. And at the end of the day, we could remove 28K lines of code. I think it's a bit more than that afterwards. And this is almost 3% of the Sentry code base that we could remove, which is huge. But I think the more important thing is that we're now running Knip in CI, which makes sure that no additional dead code is introduced. And every once in a while, I find a PR that has a CI failure of Knip because people remove some code and they don't go further and don't remove all the orphans that are created. And then they add an additional commit with the scissors emoji saying something like, make Knip happy. And yeah, that makes me happy as well to see that everybody now has to care about that code. Also, Knip got really fast recently, so in version 6, just released it. It brings a huge performance boost thanks to a rewrite where they're using the OXC parser instead of native TypeScript. And we can see in the benchmark that Sentry used to be the slowest. It's still the slowest, but with version 6, everything got way faster, almost down to 4 seconds to run it in this 1 million lines of code base. So yeah, if you want to try out Knip, it's as easy as running npx knip in your code base. See how far you can get without any configuration. And if you see some false positives, just go and add some config. And I'm sure it will show you some good things. And then you can also declutter your code base one Knip at a time. Thank you.
Well, thank you so much, first of all.